It was a cloudy night, not the best for peering into deep space. They were about to give up.
And I'm looking at the sky, and I'm noticing there's some holes in the clouds, and I'm thinking, you know, there are some breaks in the clouds. Maybe we should continue to observe in the hope we might get something.
David was always very enthusiastic, and he would really push the limits as far as the film was concerned.
But Gene Shoemaker was reluctant. Film was expensive, and the night wasn't promising. David Levy wouldn't give up. Levy won out. They took just 2 pairs of films that night. Reviewing them 2 days later, Carolyn Shoemaker knew she had something unusual.
She suddenly sat up in her chair, and she said, David, Gene, I don't know what I have here, but it looks like a squashed comet.
None of us knew exactly what we had, because it wasn't like anything we had seen before.
Seeking confirmation of their find, Levy immediately called his friend James Scotty, who was observing at Kitt Peak near Tucson, Arizona. Scotty was doubtful of their findings, but agreed to take a look.
I called him back in a couple of hours. I said, are you okay? And he said, the sound you heard is me trying to pick my jaw off the floor. And I said, Jim, do we have a comet? He said, oh yeah, you've got a comet.
A comet is an icy body, sometimes containing a rocky core that orbits the sun.
And we typically now use asteroid as being something that's rocky, and a comet as being something that's icy. The problem with that definition is I think we're beginning to realize that many objects in the asteroid belt are actually icy. And depending on where they were born, they either have a lot of water ice because they were far from the sun, or they were formed close to the sun, in which case they're pretty much water-free.
Comets can be hard to predict because their orbits can be of extremely long duration, up to 1 million years to revolve around the sun. Orbital calculations of Shoemaker-Levy 9, as the comet had been dubbed, revealed that it had passed close to Jupiter in July of 1992, and that Jupiter's gravitational forces had broken it into 21 fragments.
Comets can be pretty fragile, and so you would see one fragment here and another fragment there, but you never saw them lined up like this. And so it was a very exciting discovery. It was really a string of pearls.
Very dangerous pearls that calculations revealed to be on a collision course with Jupiter.
This was fantastic news to Gene, who had always wanted to see an impact.
But reactions in the scientific community were decidedly mixed.
I remember the day that it was announced that Shoemaker-Levy 9 was in fact going to hit Jupiter, because a graduate student came into my office and said, have you heard, a comet's going to hit Jupiter? And I said, Jupiter's really big. Comets are really small. It's not going to be a big deal.
And this was the question. What kind of an impact would a big snowball hitting a gaseous giant of a planet make? Gene Shoemaker believed that the incredible speed of the Shoemaker-Levy object would create a spectacular collision with Jupiter. But again, few believed him.
We didn't know that much about the makeup of comets, how strong they were. We just hoped for a big show.
Nobody thought that the results were going to be as dramatic as they were.
Shoemaker was right. The world watched from July 16th through the 22nd, 1994, as one after another, the fragments of comet Shoemaker-Levy 9 made a spectacular collision into Jupiter's clouds.
And these pieces kind of came in a line like a train, like a freight train, and just hit the planet, bam, 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 bam.
Plumes rose 2,000 miles above Jupiter's cloud tops.
The fact that you could have fit the Earth within the dark cloud coming from one fragment strike, that was pretty awesome.
Awesome might just be an understatement. A 2-mile-long fragment in particular, labeled Fragment G, struck with an energy of 6 quadrillion tons of TNT, 600 times the power of the world's entire nuclear and conventional arsenal.
This is something that really happens once in a lifetime. Our understanding of the solar system is evolving by leaps and by bounds as we watch. That's the way to do science.
It proved beyond any doubt that impacts were not only possible, but inevitable and very dangerous. Some speculate that if a piece of a comet the size of fragment G struck Earth, it could extinguish most life on the planet. An awareness of the continued danger of collisions in our solar system is just a part of Gene Shoemaker's legacy. In 1997, he died in a car accident while studying impact craters in Alice Springs, Australia.
I remember I was at a dinner where somebody asked someone that I know well, who is the greatest planetary scientist, who is the greatest geologist of the 20th century, and he didn't even think. He said Gene Shoemaker, without a doubt.
Gene Shoemaker helped the world understand that impacts within our solar system are still disasters waiting to happen. But have massive impacts also helped form our planetary neighbors, change their makeup, and even their posture? For instance, why does Mars have two faces? And why is Uranus resting on its side?